Hi everyone, this is my new tutorial on Keysight ADS, and today we're just going to do some little simulations and some Monte Carlo, and we'll try to do it within a few minutes. Alright, we don't want to extend our video too much, so the goal of the video is just to show you how you can use this thing, and also some of the simulation tools like Monte Carlo, or it could be your risk parameter or things like that, right? But today we're just trying to do it as short as possible, or maybe AC sweep would be a great one to add here. Alright, so what you're gonna do is, you can see here some lump component around, right? And as you kind of go down, the list kind of keeps going up. So what I'm gonna do is I'm going to place some lumped component of, for example, a resistor, which could be 50 ohms, great. Maybe another resistor here, which could be a 50 ohms as well. By the way, I don't think I need that because I'm gonna use a 50 ohms termination later on. But let's just build a fifth order LC ladder filter. So I can do, for example, 3 inductor, then I have some cap in series. I can do Control and R and rotate it, and here you go. So once I do it, I need to connect them together, right? So I can use either click on here inside a wire, or I can just do Control and W, which is my favorite, and then I'm going to just like start linking them up together here as I'm kind of doing. And then as you can see, this is as well. No. Then here we go. All right, now I'm gonna go on the top, and I'm trying to find the ground because I need to ground them up. So here we go. I'm just gonna ground them, and once I do it, I'm gonna try to find a kind of a simulation or any kind of like a source. All right, so I'm gonna try to find a frequency source. So as you can see on this palette, they do have a lot of them, like a simulation AC. I definitely need a simulation AC. I also need a frequency domain. So if I go into frequency domain, I definitely can see the BCC around here, then VSC. I'll just use the VSC for now. So I'm gonna use it here, and then I'm gonna just connect them together as well, because sometimes I literally forget to do that, and I don't want to forget about it. Now I'm gonna add some termination here, like a 50 ohms termination to the ground. So what I'm gonna do, I'm just gonna write term G, and here you go, the port impedance terminations. So it's for S parameter with a grounded reference. So you can also use this if you want, or you can just like terminate as regularly as you do. But I wouldn't bother. I'm just gonna use it because I like to use it all the time, and that's kind of also a termination for any of the sources. But if you have these two guys, you can do easily S parameter simulation. All right, so that's it. And excuse me, I was about to sneeze. All right, so that's it. You can now I can do AC sweep, or I can do a Monte Carlo just to see how these things are cutting things off. You can have some kind of exact precise values to make it like a 100 megahertz of filter, low pass filter, or 200 megahertz or 500 megahertz or even 50 megahertz of low pass filter. By this point I don't really care, because I just want to create a filter so that we have something to talk about, right? All right, let's just first do maybe a AC sweep. All right, so you can do from here, you can go like from this palette, you can click on here, then you can come to the simulation AC, and then click on the AC, and I'm just gonna place it right there. And once I do it, I'm kind of almost set. I just need to kind of define where would be my sweep starting and end point is. I want to just do from DC because I don't really know what the values of this filter is doing. It's kind of very straightforward, 1 nano Henry and 1 picofarad of cap and inductor, which is really, I'm not really sure what it's gonna do with that one. I'm just gonna just trying to simulate some random crap. All right, so I'm gonna do like 2 gigahertz here, and I'm gonna try to do 10 megahertz is not too bad. 10 megahertz, I guess. And numbers of point shoot. Well, it's automatically kind of figured out how many numbers of point I need here, right? So all right, I'm done. I'm just gonna click apply, and once I do, you can see it's change. And now I'm gonna just click on the simulation, and once I click on it, it's telling me, hey, there is no names node were found, no node bolts will be available for plotting. To name the node, click the name tool in the toolbar. So what it's saying that you have a nice looking schematic ground there, but guess what, you don't have anything to probe, right? So what I'm gonna do, I'm gonna click here, I'm gonna say it as a out. So that's basically telling me that, all right, whatever is coming out of here is basically out. And maybe here I can name it as like a in. Oh my gosh, come on. I'm gonna click like an in. So now I'm giving two variables. That means like I give it two probes so that I can see what's coming in and what's coming out. So once I do that, and if I run the simulation, now it's starting and it's finished. It's running, it's finished. All right, now we are in the results section, and to plot the results you can just pull up a table, what they call like a rectangular plot, whatever. You just click on it, and then you can do add buses, select DVM or magnitude. I'm gonna go with DV, and out bus is frequency. So my frequency would be in my x-axis and my out would be in my y-axis. So right now, when I'm done, here you go. It's kind of look like a very straightforward graph, not really too much. So what if I change some values here? For example, I want to change some values of the inductor or capacitor. I'm gonna just click on the history here and turn it on so that I can see what is the difference. And I'm gonna go back and I'm gonna change some of the values. For example, I'm gonna change the inductor to like 55 nanohenry. I'm gonna change this one into, my gosh, see, I don't even have a space to breathe. Like 22 nanohenry. I'm gonna change this one as like a 22 nanohenry. I don't really know what it's gonna do. I'm just trying to do something random thing as much as possible. Now I'm gonna go again and simulate the results, and once I do it, I expect it to plot it over. So here you go. So this is the new plot that we are getting right now, and I'm not sure why the previous plot is looking a little weirder, but as you can see, it's kind of like a plotting over each of them. So now again, if I change the cap values to like 10 picofarad and here like 10 picofarad, and if I just do the simulation again, and you can also see now it's a different value. It's kind of more like a good low pass frequency, like low pass filter. It's kind of having a cutoff here in the like around 0.45. You can also just plot a this kind of stuff and trying to see what is really going on. Like if you just put on the traces, then you can definitely see that what is the frequency it is and what the values is right now and everything. So all right, this is one part of it. Now good thing we got a nice looking filter, and I want to do a Monte Carlo on it. I want to see that, okay, how it's gonna perform in a real life value, I mean in some tolerances. So I want to do a Monte Carlo simulation. I know the video is almost 8 minutes, but I guess it's super important to show you how to do the Monte Carlo analysis as well. So let's do that. I'm gonna just write on Monte Carlo on my this part. Here's the Monte Carlo, and I'm just gonna place it, and I need to do some settings here, but I want to make sure that I'm not missing out of any other thing. Seems like no, I'm not. So now I have to change it. I have to manipulate it based on this guy, right? So what I'm gonna do, I'm gonna do simulation instance name, and that will be your AC1. So let's just write it there. So you can do a AC1, and now you can set your number of times you want to run your Monte Carlo, and you have to make sure that your all iterations are saved, and you can change the settings based on your need. 250 seems like a reasonable to me for this kind of simulation, and I want to do something just to make sure that I guess it's gonna plot again. So let's just run it because we have our Monte Carlo simulation here, but we have to also do something on our simulation setup. Let's click on the simulate, and then let's click on the simulation variable setup. And as you go there, you can see tuning, optimization, statistics, and then DOE. Then we're gonna go to the statistics, and we're gonna select these values because we want to vary them with tolerances. All right, so I have 5 of them. You can do a standard deviation, or you can do a percentage, or you can also do like, yeah, I sometimes I just do percentage, sometimes I don't, but I don't really care right now. I'm just gonna give whatever the ADS is choosing because it's just a tutorial. So let's click OK, and now let's just run it and see what we get. So it's running. Here you go. It's trying to simulate it, and here you go. It's our Monte Carlo simulation right there. It's right there. And you can definitely plot it to see what the values look like. But a quick check is like always, if I click on here, where is it? Like here, and now if I pull it down the right side, you can definitely see that how the values have been changing as I'm kind of going on to the right side. And there's some kind of equations and manipulations that you can do, but we're going to talk about it in the next video. I don't want to extend it more than 10 minutes, but it's already been more than 10 minutes. But this is your basic idea. This is your basic idea about the Monte Carlo essay analysis, and then some of the plotting things that you probably should know. Thanks for watching, and see you on the next video.